So the next thing we get to talk about are these things called scalars and vectors, and then with these vectors we're going to break them into components. So the good news is we've actually talked about some of these things already. We've talked about scalars, we've talked about vectors, we just haven't really defined what they were, so now's the time to do that. So we'll start with this thing called a scalar. So we've talked about scalars before, but how we'll define it is it's a quantity that only has magnitude. On the other hand, a vector, so it's something that has both magnitude and direction. So let's give a couple examples of these things. So what I've got here is a big list of the terms that we're going to use throughout this first semester, or maybe a couple of them for a second semester. So let's start with the ones we know already, right? So we know distance. So we know distance has only magnitude. We don't care about direction, meaning we never put a negative sign when we talk about distance. So clearly distance is a scalar. On the other hand, displacement, we do care about the direction, so it is a vector. The same thing with speed and velocity. Remember what speed is our distance divided by time. We don't care about any direction, so it is a scalar, which makes velocity a vector. Acceleration, it is a vector. We associate a negative, a direction for it, like down for acceleration due to gravity. Time is a scalar. We don't care about, there is no negative time. It doesn't make any sense, so it's only, there's no direction for time. Mass, we don't care about any kind of direction for mass. Mass is just that the physical quantity of an object. Temperature, scalar. Energy, another scalar. Leaves force, we haven't talked about quite yet, and momentum. So remember what we said, right? So these things that are scalars, have only magnitude. Remember what magnitude means? Magnitude just means how big. So a vector has magnitude, so we care about the size, but we also care about the direction. Okay, so keep this in mind. So if I ask for velocity of something, I want a direction. Okay, if I ask for the acceleration of something, I want and need a direction. Same thing with force and momentum, displacement. I need directions for those things. All right, let's see how that's going to apply to what we need to do for this unit. So let's go back and talk about displacement again. So let's say I walk 200 meters to the east. Okay, let's say I walk another 300 meters to the east. What is my displacement? So this is kind of an easy one, right? Because we know displacement is where you start compared to where you end up. So our displacement is 500 meters east. Okay, let's go a little further now. Let's just say now that instead of having these things right after each other, let's say this. Let's say I travel 200 meters east, and then I travel 300 meters north. Now, what is my displacement? So remember, we said our displacement is from where you start to where you end up. More specifically, from where you end up compared to where you start. So now we just can't add them up, right? Because it's not 500. This distance from here to here is not 500 meters. It's something else. So the question is, how do I get that? So if this is a right triangle, and it is because this is east and that's north, so this is 90 degrees, which means this is a right triangle, so I can do Pythagorean Theorem. So I'm just going to Pythagorize this guy. If you recall what the Pythagorean Theorem is, it's just a squared plus b squared equals c squared, where this is c, and it doesn't really matter if this is a or b, as long as the hypotenuse is c, right? So if we're trying to find this c, right, we're trying to find the hypotenuse. Now don't forget, I'm looking for c, not c squared, so this is going to be the square root of a squared squared plus b squared. So we take the square of each of those sides, then take the square root of each of those, crank them out, get a number. We get 361 meters. Okay, but, so here's what I said. I said that this is a vector. And I said vectors have both magnitude and direction. What we found was only the magnitude. We need a direction. So what does that mean, you need a direction? That means I need to give you this angle. Let's just call it theta. So to do that, we need to use some trigonometry. Let's take a look at our old friend, the right triangles. Remember, the right triangle's got one of their angles is 90 degrees. So let's call this angle here theta. Okay, if this is our theta, that makes this our adjacent side, which makes this our opposite side. And of course, that makes that our hypotenuse. So you also probably remember the relationship between this angle and these sides. The relationship between those are our trigonometric functions. So in this class, we're only just going to use sine, cosine, and tangent. We'll use the inverse of these functions, but we're not going to use the hyperbolic functions. So remember that sine theta was just our opposite over our hypotenuse. Our cosine is our adjacent over hypotenuse, and tangent is opposite over adjacent. I'm sure you guys remember this from, I don't know, whenever you took, you learned this, SOHCAHTOA. It's just a little mnemonic to help you remember what these things are. So we got sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. All right, so knowing all this, we need to get our angle. So let's go back to our problem, right? So I need to get this angle right here. So if I get that angle, so I've got this 300 and this 200. Now I did figure out this. However, I'm not going to use that hypotenuse because that is a calculated value, and I'm going to try and avoid doing that if I can. So if I've got, this is theta, this is my opposite, this is my adjacent, that means I need to use my tangent function. So tangent theta is opposite over adjacent. Now remember, I only want the angle, I don't want the tangent of the angle. So if I want the angle, I want the inverse tangent of opposite over adjacent. So inverse tan, my opposite is 300 meters all over 200 meters, gives me 53.6 degrees. So I need to be a little more specific with this. So I'm going to say it's 53.6 degrees north of east. Okay, so I'm kind of northeast there, but I'm going north of the eastern side. So does that make sense? If I can just show that this is east and my angle swings up north. So if it was this way, it's perfectly east, so I got 53 degrees north of this east vector. So this is what we're going to be doing in this particular unit. We'll do a lot of practice for this. Yeah, hold on one second. My son's calling me to tuck me in. Okay, sorry. So we'll be doing lots of practice with this in this unit. So we have to get good with using these trig functions. It's critical we use these. We get good with these. A couple notes on this though. Please know how to do this in your calculator. In this class, we are going to be in degree mode. So if you're in radian mode, it's not going to be good news. So please use degree mode, and we'll be okay. So we'll do lots of practice in this with this in class, and I will see you then.